Architectural physics is an important part of architecture, which embodies the technical and scientific attributes of architectural design discipline. It constitutes a scientific system of architectural technology together with architectural structure and green building technology, and is the theoretical basis for building energy conservation, ecological architectural design, and green building evaluation. Architectural physics includes three parts: architectural thermal engineering, architectural optics, and architectural acoustics. Its basic principles, design strategies, and technical measures penetrate into urban planning and design, architectural group layout, architectural space design, building material selection, architectural structure design, construction technology and management, and run through the whole process of architecture. Architectural physics is a compulsory professional basic course for architecture and related majors. The course focuses on explaining the basic knowledge and basic principles, design principles and technical measures of architectural physics, and cultivate the ability to analyze the professional problems by using the basic principles and the basic knowledge of architecture physics. The theoretical basis of building thermal engineering is thermodynamic and heat transfer. The influence of indoor and outdoor heat and moisture on building envelope and the indoor thermal environment is studied. Solar radiation, temperature, and humidity of outdoor air, wind, rain, snow, and other factors are collectively referred to as outdoor heat and humidity. Indoor air temperature and humidity, heat and water vapor emitted by indoor production and life are collectively referred to as indoor or heat and humidity. The indoor and outdoor heat and moisture effect often changes, not only directly affect the indoor thermal environment, but also affect the durability of buildings to some extent. Building thermal design studies how to create a suitable indoor thermal environment by means of architectural design to meet the needs of people's work and life. Buildings should not only resist the surf cold and heat, but also send out indoor heat and moisture, and consider the sustainable development of human settlement, saving investment and energy consumption. Building thermal theory and method are the basis of building energy-saving design. How to combine the passive thermal design method with urban planning and architectural design is the current research direction. Architectural optics studies the rational use of natural light and artificial light in buildings. Natural lighting is greatly influenced by season, day and night, geographical location, and climate change. Artificial lighting consumes energy and is easy to cause indoor overheating. By means of architectural design, natural lighting and artificial lighting are organically combined, and the basic characteristics of architectural optics are reasonably used, according to the function and artistic requirements of buildings. A good light environment can be created. From the perspective of energy conservation, natural light is a rich light energy resource, and the study of natural lighting of buildings is conducive to the development of green buildings. The research objects of architectural acoustics include two aspects: indoor sound quality design and noise control. By studying the laws of indoor sound wave transmission and acoustic processing methods, good hearing conditions are ensured in the room, and the noise transmission inside and outside the room is controlled by technical means. The basic theory of architectural acoustics can be divided into three design theories and methods: geometric acoustics, statistical acoustics, and wave acoustics. Using geometric acoustic method to study the distribution of early reflected sound to strengthen direct sound can improve the uniformity of sound field and avoid sound quality defects. The statistical acoustics method can be used to study the growth, steady and attenuation process of acoustic energy density under continuous sound source excitation from the perspective of energy. The subjective evaluation criteria and the acoustic objective measurements are combined to provide scientific basis for indoor acoustic design. The application of wave acoustics theory can solve the resonance phenomenon in the interior space of the building and the surface of the enclosure structure, so as to improve the indoor sound quality. It is an important aspect of architectural acoustics research to control the building environmental noise and ensure that the building interior reaches a certain quiet standard. Due to the wide use of lightweight materials and lightweight structures in modern buildings, the ability of air sound insulation is weakened. It is necessary to develop new wall structures to meet the requirements of sound insulation and seek efficient component connection methods to reduce the propagation of solid sound. The development trend of modern architecture is to use the basic theory of building physics to calculate and quantify the parameters of the building itself and indoor environment. Collect the information of the building physical environment and control the building physical environment through sensors, big data, the Internet of Things, and other technologies so as to make the traditional building energy efficiency, environmental protection, comfort, and intelligence. Future buildings will be more in line with the integrated development of human and architecture, human and nature, and human and environment. By building a healthy, green, and environmentally ecological environment, healthy life and smart life will become a reality. In order to achieve this goal, let us walk into the classroom of architectural physics, understand the knowledge of architectural physics, and jointly create a green and livable human whole.